So to answer the question a bit deeper on the technical side, it starts really with the tendon drive, which gives you kind of this adaptable, compliant joint, just like we are, right? So like humans are very adaptable and soft and compliant. And this is one of the things that makes us so great manipulators. So this is common misconception that we are so fast. We are not, right? Or we can move very fast, but we're not very fast in sensing. So like if I'm picking up this cup, I'm actually not really fast enough to sense that I'm touching the cup and stop my hand. What actually happens is that I see the cup, I know roughly how to interact with the cup. My muscles actually tense up to a certain impedance to brace for the contact that will happen, and then you collide with the cup. And then you collide with the cup with very well governed contact dynamics because your brain is so good at like tuning your muscles for that specific contact. Now our robots work exactly the same. We actually modulate the field in the motors to have the correct kind of tension and preload in the cables for these kind of contacts. And this enables you to do very safe, lightweight contacts. And this is passive in the dynamics of the system, which I think is incredibly important. So this is not something we can just control in software. When our system moves, there is just very little kinetic energy. Because normally in a robot, like if you think about like the joint moving at like a human speed, and you have a gear inside here, typically it would be like about 100 to 1 ratio. So something inside here rotates 100 times faster than my arm. Now you can think about something rotating 100 times faster than this, and then I can say like, oh, can you stick your hand in and touch it? You don't want to do that. That inertia, that energy that's in that spinning system is enormous. And you can actually usually compute this, which is an interesting exercise to do. So if you look at some of the typical robotic systems like humanoids, and you compute what's the effective, what's the, say this, what is the effective inertia, equivalent inertia at the hand to the energy in the system, it comes out at about 15 kilograms. So you can, and about 25 for your feet. So you can think about strapping a 15 kilogram kettlebell to each hand and a 25 kilogram kettlebell to each foot, and then you can go about your daily activities of living. And it's very fun to do this. You should, I've actually done it and it's really fun. You should do it because the first thing you'll notice is you'll start walking like a robot.